Have you ever just stopped and looked at the world and wondered how incredibly complex things can come from, well, from really simple beginnings? Like, how does a flock of birds move like it's a single flowing creature? Or get this, how does a thought, an idea, a feeling just pop into your head? All these intricate patterns, they seem to appear out of thin air, but it's not magic. They all share a secret, a powerful concept called emergence.
It really all starts with a mystery. I mean, we see this breathtaking order all around us. You've got termite mounds that are basically cities. You have our own bustling human cities, even the entire global economy. But here's the crazy part. There's no central planner. There's no single boss directing every little action. So how on earth does it happen?
And that, right there, is the core question we're going to dig into. How do these individual, simple little pieces, just following their own basic rules, somehow come together to create something that is so much more than what they are on their own? Let's look at a few examples to really see what I mean.
Okay, so look at a single ant. By itself, its intelligence is, well, it's pretty limited. It's just following a few simple chemical trails and instincts. But when you get thousands of them together, interacting, something incredible happens. They build these massive cathedral mounds, complete with ventilation systems and even their own fungal farms. And the most amazing part? No single ant has the blueprint. Not one of them knows what they're building. The design emerges from all their tiny actions combined.
Or let's get a bit more personal. Think about your brain. A single neuron is basically just a tiny biological switch. It fires an electrical signal, that's it. But you get billions of these simple switches interacting, and suddenly you have the most complex thing we know of in the universe: a conscious thought, a memory, a feeling, the experience of the color red, or the abstract idea of justice. It doesn't exist in any single neuron. It emerges from the whole network.
And here you can see it in motion. A single starling in a flock is just following a few basic rules. Try to match your neighbor's direction, don't get too close to them, and, fly away from hawks. Simple. But the result is this absolutely breathtaking aerial dance, a murmuration. It's this stunning, fluid display that moves as if it were a single intelligent organism painted across the sky.
So all these mysteries, the ant colony, the thought, the flock, they're all unlocked by one fundamental principle: emergence. And this is the key to understanding complexity, not just in nature, but in our own societies and even in the technology we build.
This definition really gets right to the heart of it. The key words there are interact and wider whole. Emergent properties aren't hiding inside the individual parts. It's like you can study a single H2O molecule for 1,000 years, and you will never, ever find the property of wetness. Wetness only appears, it only emerges when you have millions of those molecules all tumbling over and interacting with each other.
To make this even clearer, a philosopher named G.H. Lewis made this brilliant distinction way back in 1875. He was really ahead of his time. He separated things that are just resultant, basically a simple sum of the parts, from things that are truly emergent.
This table makes it super clear. Look at the resultant column. If you mix sand and rocks, what do you get? A pile of sand and rocks. It's predictable, a simple sum. But now, look at emergent. If you take flour, eggs, and sugar, and you add heat, that is, you make them interact, you don't just get a hot pile of flour, eggs, and sugar. You get a cake. Something with totally new properties, like fluffiness and a golden crust, that were absolutely nowhere to be found in the original ingredients. That transformation, that is emergence.
But okay, the story gets even deeper, because it turns out that not all emergence is created equal. Scientists and philosophers make this really key distinction between two different types, what they call weak and strong emergence.
And the real difference between them comes down to a question of predictability. Can we, even in theory, ever truly understand the whole thing just by simulating all the little parts? All right, so weak emergence is the kind we can sort of wrap our heads around. As you can see, we can simulate it. We can program a computer with the simple rules for individual cars, hit run, and watch a traffic jam emerge on the screen. It's bottom up. But strong emergence, that's a more radical idea. It suggests that some properties are truly brand new and can't be reduced back down to their parts, no matter how powerful your computer is. It even brings up this wild idea of downward causation, where the big emergent pattern itself, the whole system, actually starts influencing the very parts that created it. And consciousness is the classic, and yeah, the most hotly debated example of this. And this is exactly why the philosopher Mark Bedau said that strong emergence feels uncomfortably like magic. It really challenges that core scientific instinct to break everything down into its simplest components. It suggests that at certain levels of complexity, genuinely new forces, new properties, can just come into being.
It's a fascinating and, for a lot of people, a really controversial idea. Now, this isn't just some abstract philosophical debate. The brilliant physicist Philip W. Anderson wrote a famous paper back in 1972, and he titled it simply "More is Different." His whole point was that emergence isn't just a weird quirk. It's a fundamental principle for how our entire reality is structured.
So here's the crucial takeaway from that. Even if we had a theory of everything, a single equation explaining every fundamental particle, we still couldn't use it to predict biology or psychology or economics. Why? Because at each new level of complexity, entirely new rules and new behaviors just emerge. More really is different.
And you see this principle absolutely everywhere in science. I mean, the origin of life itself is the ultimate emergent event, right? That mysterious leap from lifeless chemistry to a self-replicating organism. But it also happens in simpler ways. Just think about a phase transition, like water freezing into ice. You have the exact same H2O molecules, but suddenly a new rigid crystal structure, ice, emerges, with totally different properties.
And this isn't just about physics and chemistry, it's about us. Look at the global economy. It's this mind-bogglingly complex system that no one person designed, no one controls. It just emerged. Or think about language. No committee sat down and invented the English language. It evolved, it emerged from countless daily interactions between millions of people over hundreds of years.
And now, here's where it gets really interesting. We're not just observing emergence anymore. We're actively building with it. Engineers are creating swarms of simple little robots that can cooperate on complex tasks, just like an ant colony. And in AI, we're seeing these complex, intelligent behaviors emerge that even their own creators didn't explicitly program or predict. We are engineering emergence, and understanding it is absolutely vital.
So where does all this leave us? Well, once you start seeing the world through the lens of emergence, it kind of changes everything. It shifts your focus away from the individual components and onto the relationships between them. And this really is the fundamental shift in perspective. The real magic isn't in the individual pieces, the ants or the neurons or the birds. The creativity, the novelty, the complexity, it all happens in the connections, in the space between them. The world isn't just a pile of things. It's a web of relationships.
And that leaves us with one last thought to chew on. Every single one of us, we're all parts of these vast emergent systems. Our societies, our economies, our online networks. In our daily lives, we're all following simple rules in our interactions with each other. So the question is, what complex, unpredictable, and amazing new wholes are we helping to create right now without even realizing it?